Let's take a look at the distributive property of exponents. If I multiply two numbers together and raise the result to some power, let's say 4, I could look at this a couple of different ways. Using the order of operations, I can think of this as 6 first because it's inside parentheses. But what's in the parentheses is raised to the 4th power. So this is 6 to the 4th. 6 to the 4th is 6 times itself 4 times. 6 times 6 is 36. And again, and multiplying these gives me 1,296. That's a pretty big number. But let's look at it a different way. Remember that to the 4th power means times itself 4 times. So what this is saying, if you look at it the right way, is 2 times 3 times itself 4 times. I've used the dot for multiplication between the 2 and the 3 because that's how this is expressed in the original problem. And I've used the parentheses to mean multiplication of something times itself a certain number of times. But dots and parentheses, at least in this context, really mean the same thing. So I could rewrite this like this. No parentheses now, just dots in between everything. Now, using the commutative property for multiplication, I'm going to reverse the order of these two numbers here. 2 times, not 3 times 2, but 2 times 3. Then I'll write down the rest of the problem, and then I'll do the same thing again here. Not 3 times 2, but 2 times 3. And write down the rest of the problem. Now I'll do it again in this position. Not 3 times 2, but 2 times 3. And write down the rest of the problem. Then I'm going to do it again here. Not 3 times 2, 2 times 3. Times 3. And again, 3 times 2 becomes 2 times 3. And one more time. 2 times 2 times 2 times, not 3 times 2, but 2 times 3 times 3 times 3 times 3. Now that I've done all that rearranging, watch this. This is 2 to the 4th power. I've got all my 2's together, and a number times itself 4 times is that number to the 4th power. The same things happen with the 3's. This is 3 times itself 4 times, and this times right here can be brought down in between them. If I skip all of this, I end up with 2 times 3 raised to the 4th power equals 2 to the 4th times 3 to the 4th. In other words, take two numbers and multiply them together and then raise that to a power. That's the same as raising each of the individual numbers to a power and then multiplying. Here's our shortcut for the distributive property of exponents. Let's do an example. 3 times 5 all raised to the 2 is the same as 3 to the 2 times 5 to the 2. 3 to the 2 is 9. 5 to the 2 is 25. 9 times 25 is 225. I could also have thought about this as 3 times 5 is 15. Now square the result. Well, 15 squared is also 225. So this property clearly holds true. What if we don't always have numbers? And frankly, this is algebra. That's going to happen a lot. What is 3x all squared? Simplify to. Well, here I can't multiply 3 times x first because I don't know what x is. But I can rewrite this as 3x times itself twice. This means multiplication too. So these are all multiplied. Using the commutative property of multiplication, I can rewrite this problem as not x times 3 here, but 3 times x, and then times x. And that gives me 3 squared times x squared. 3 squared I know is 9. X squared, well, there's nothing I can do with that, but just write it as x squared. I've also left out this times dot this time. It just tidies things up a bit. Of course, I could always have taken the shortcut. 3x all squared is 3 squared x squared. This, of course, becomes 9x squared. Same thing. The real power in these properties, though, is when you combine them. There are a lot of different examples, and there's an infinite number of problems that contain combinations. Here are a couple of examples. 4x squared y to the 5th, all raised to the power of 2. Since I have a large expression here, raised to a power, I'm going to start by using the distributive property of exponents and apply this squared to everything inside. That means rewriting this problem as 4 squared times x squared squared times y to the 5th squared. Well, that's great, but I've got more work to do. First of all, I know what 4 squared is. 4 squared means 4 times itself, or 4 times 4. And 4 times 4 is 16. Now, using the power property, I can rewrite this piece here and this piece here. The power property says a base raised to a power raised to another power, you multiply the powers. So x to the 2 becomes x to the 2 times 2, or x to the 4. Y to the 5, all raised to the 2, becomes y to the 5 times 2, or y to the 7. I can leave it like this, or I can tidy it up and take those dots out. Here's my final answer. That's simplified as much as I can make it. Here's another example. X to the 4th raised to the 3 times x to the 2 raised to the 5. This piece here times this piece here. And this piece here uses the power property. A base to a power, multiply the powers. Here I have a base of x raised to a power, multiply the powers, and I get 12. This piece gives me a base of x raised to a power, multiply the powers. But there's more I can do. Now I have the same base raised to 2 different powers multiplied. And that's the product rule. That's x to the 12 plus 10, or the x to the 22. Two y all cubed times 3y squared. The thing to watch out for here is that this squared is not outside these parentheses. So I'm not going to be squaring the 3. I'm not supposed to. There's no exponent here. There's an exponent on this y, but not on the parentheses. On this piece, and this is multiplication, on this piece I'm supposed to take all of this and raise it to the third power. Using this shortcut, I can get the first thing to the power, that's the 2, times the second thing to the power, that's the y. So all I've done now is simplify this piece. Now I'm going to multiply that by this piece here. But this piece here is tricky, because remember, there's no exponent out here. I'm not supposed to raise 3 to the second power. If I were, there would be an exponent on the outside. So 3 does not get raised to any power. And the y, well, it's already raised to the second power, so let's just copy it down that way. Now, these are all multiplication. So I can use the commutative property of multiplication to rewrite this problem. Not y cubed times 3, but 3 times y cubed, and then times y squared. Now I know what 2 to the third is. It's 2 times 2, which is 4, times 2 again, which is 8, times 3, times, now I'm going to use the product property. I have a base raised to a power times the same base raised to a power, so I can add the powers. Finally, I know 8 times 3 is 24, and I know 3 plus 2 is 5. My final answer is 24 y to the 5th. This expression simplifies to this expression. Our last example for now. It's getting kind of messy, but we can take each piece one at a time and just work with that. Ultimately, multiplying them together and simplifying as we go. There's not so much an order of operations here as there is in arithmetic, but it's a useful way to think of these. If I think parentheses first, then I'll be more inclined to distribute this 3 across these parentheses. Remember, the distributive property of exponents says take the exponent on the outside and apply it to each of the things on the inside. Of course, this only works if this is a product. So let's do that. Let's rewrite this piece as each of the pieces inside raised to the third power. But what are the pieces inside? Well, the first one's a 2, the second one is x squared, and the third one is y to the 5th. Okay, let's do the same thing over here. We'll take each of the pieces inside the parentheses and raise it to the second power. What are the pieces inside? A 3, x to the 4th, and a y. Now I can use the power property. A base to a power, you multiply the powers. I don't have that here. I'll just copy that down for now. But I do have it here, a base to a power, multiply the powers. And again, a base to a power, multiply the powers. For the second half, I get 3 squared, and a base to a power, multiply the powers. Now, there's no exponent written there, but there's an invisible one. So you could also think of this as y to the 1 times 2. Or you can just think of it as y to the 2 power. Either way, you get y squared. Now I can use the commutative property of multiplication, like I did in a previous example, to change the order of these two things and then the order of these two, and then it would take me forever. Well, it'll take a while anyway. Or I can jump to the punchline. I can say this. I know that one at a time I can change the order of any of the pieces in this multiplication problem. If I can do that one at a time, then I can skip straight to having all of my numbers multiplied by each other, followed by all of my x's, and finally times all of my y's. This lets me simplify the numbers, the x's, and the y's. The x's are easy now. In this step, we're going to use the product rule. A base to a power times the same base to another power, you add the powers. 6 plus 8 is 14. And for my y's, I get 15 plus 2, which is 17. Here I have to be careful. These bases are not the same, so I can't use that rule. Fortunately, I do know what 2 to the third is. 2 times 2 times 2 is 8. I also know what 3 squared is. 3 times itself, 2 times 3 times 3 is 9. And finally, I can multiply these two together, drop these extra dots, and my final answer is this. 72, x to the 14th, y to the 17th. I could actually have jumped to the last line from about here. I did this step especially because I wanted you to see that all I'm doing by changing the order of these different pieces of this puzzle is the commutative property of multiplication. But I know that I can do that, and so I can jump straight to, what is 2 to the third? It's 8. Where's my other number? It's over here. What's 3 squared? It's 9. Now let's look at x's. X to the 6th times x to the 8th. Yes, they're separated by a few pieces, but it's still x to the 6th times x to the 8th. So I could just go x to the 6 plus 8 is 14. And finally, y to the 15th times y squared is y to the 17th. I'll need to do this multiplication. But then I get the same answer as I did before. These steps are optional if you're comfortable with the commutative and associative properties of multiplication and addition. In this case, it's all multiplication. I did this step, and then again this step, because this may be a new idea for a lot of you. And in fact, the fact that we can even get away with reordering things may be a new idea for some people as well. If you don't need to write all of this, that's fine. Please be careful that you don't take too many shortcuts for your level of understanding. Shortcuts are fine as long as they don't lead you astray.